Select one of the material and components type listed below. So we're going to select polymer. Okay, so you select polymers. You would obviously write down in here because you learned about plastics in year and you've done some work. For the material or component type selected, describe one stock form in which it is commonly available. Okay, so let's have a look at it. I think the best way to describe it is, before we start, is to look at, and there are different types of stock forms for plastics. So a stock form is the type of shape that a material comes in. So for example, for metals you have different types of sections, different types of rods and bars. Okay, for wood it's different types of like sheets, dowel. You have different sections as well. You have planks, boards, and so on. For metals as well, you can have sheets as well, and different gauges. So you can see where the gauge system comes in. So the larger the number, the thinner the material. Okay, and then for polymers, which we chose to answer the question for polymers, you can see that they come in different sections. So they come as bars, as granules, they come as sheet forms, they come as rods, they come as sections as well, they come as solids, they come as different types of shapes and extrusions. Okay, so you can have ones where they have slots in them and so on. So this is what the question is referring to. So let's go back to that question. Okay, so it says for the material or component type, describe one stock form available. So let's just put down the different types we just talked about anyway. So you would have form, you would have rod, powder, granules, you can have foam, films. They come as solids by length, width, gauge, as you saw with the metals. You have different types of gauge and diameter as well for plastics. Okay, so any two of these would get you the marks. Okay, right, so question 16.2, it says 1/4 of the width of a piece of material is 45 millimeters. Calculate the total width of the piece of material. So you would get 1 mark for the calculation. So let's do that now. So it will be full length equals 45 times 4. This would get you the first mark. So let's put in brackets 1 mark. And then so full length equals 180 millimeters. And there's the answer. Okay, so you get the 2 marks there. Question 16.4. Sorry, question 17.1 is coming up. Apologies. So question 17.1. To answer that question, let's read the question first. So, question 17.1. State an example of a commercial process. Well, so for polymers, you could put down the following, but we're going to concentrate on vacuum forming this time round. But you should revise injection molding as well. Okay, so in the exam, you should be trying to answer the question on polymers, and also for the real exam as well. That's what you should be aiming for. So for us, we're going to talk about either you could put down injection molding or you could put down extrusion. So any one of those will get your mark, or vacuum forming. Okay. Then it says question 17.2. Use notes and sketches to describe how the process given in your answer to question 17.1 would be carried out. So we're going to concentrate on vacuum forming. We're going to concentrate on. So let's go, rather than me drawing, I'll show you images off the internet. So if we look at vacuum forming process, we'll get an idea of how it works. So if you did notes based on this, so to access this, if you go to technologystudent.com vacuum forming, and I'll say again, technologystudent.com vacuum forming, you can see these notes, okay, these drawings. Memorize these drawings and notes for the exam and you should be okay. So if you to use this and answer that particular question 17.2, okay, having a former, putting a former inside the vacuum former chamber, put a sheet of polystyrene, high density polystyrene over the chamber. Use a toggle clamp it in place, heat up the heating element. When the polystyrene becomes soft and starts to bow in the middle, you then press the vacuum pump which sucks out all the air. Okay, it sucks out all the air, and then you pull the platen lever or the platform lever. This takes the form upwards and forces it into the polystyrene sheet, causing it to form a mold around the form, and then you end up with the vacuum formed shape. Okay, so that's how you would answer the question. So technologystudent.com, vacuum forming. If you do a search for it on Google, you should be able to find it. Okay, so now let's move on now. The next. So let's go to question 17.2 we've already answered. So it's now question 18. So question 18 says, to my be at all stages of a product's life. This includes when sourcing raw materials for manufacturing, distributing of the product. Evaluate the importance of reducing product mileage during product mileage involves leading them to add greenhouse. So that's basically essentially what the question is to get to answer. So what you do is the following. Okay, so I'm gonna type up a response level, and you've evaluated to a high depth as well. Okay, and you've used appropriate justifications and conclusions presented. So let's start now. Let's just try and answer the questions. Double click on and aircraft. Okay, so I'll get you one mark. Transport and products. Okay, sites. At the end, legends for global warming. This also reduces pollutants in. You could also talk improved air quality. Okay, you could also talk about. Now, obviously, you need to write in 4 sentences. I'm just going to shorten this for you. Improved air quality benefits to asthma. Reduced. Okay. To justify the benefits of less mileage and low salt supports